The theorem we were given was a part of Theorem 5.40 at the beginning of section 5.5, which states, let the function of a be in the reals. Suppose f and g are continuous at x sub 0, which is an element of a. Also assume that g of x sub 0 does not equal 0. Then f over g is also continuous at.
This theorem uses continuous functions, the definition of which is, let f be defined in a neighborhood of x sub 0. The function is continuous at x sub 0, provided the limit as x approaches x sub 0 of f of x equals f of x sub 0.
We begin our proof by assuming that the limit as x approaches x sub 0 of f of x exists and is equal to f of x sub 0, and the limit as x approaches x sub 0 of g of x exists and is equal to g of x sub 0.
In this proof, we use Theorem 5.18, quotient of limits, which states, suppose that the limit of x approaches x sub 0, f of x, and the limit of x approaches x sub 0, g of x, exists, and that the latter, g of x, is not 0, and that x sub 0 is a point of accumulation of the domain of f intersecting the domain of g. Then the limit of x approaches x sub 0, f of x over g of x, equals the limit x approaches x sub 0, f of x, all over the limit x approaches x sub 0, g of x.
Theorem 5.18 uses the same assumptions as the theorem we are trying to prove. Since we know that the limit as x approaches x sub 0 of f of x equals f of x sub 0, and the limit as x approaches x sub 0 of g of x equals g of x sub 0, by substitution we can see that the limit as x approaches x sub 0 of f of x over the limit as x approaches x sub 0 of g of x equals f of x sub 0 over g of x sub 0.
Thus we can conclude that the limit as x approaches x sub 0 of f of x over g of x is equal to f of x sub 0 over g of x sub 0.